Okay, so in this situation, we have an object that's moving horizontally. It says a 405 Newton rightward force is used to drag a large box across the floor with a constant velocity of 0.678 meters per second. The coefficient of friction between the box and the floor is 0.795. Find the mass of the box. Okay, so as always, step one, draw free body diagram. We have an object on a flat surface. We don't know what its mass is, so I'm going to put an M inside the box. I don't know what M is. The ground, the floor, is supporting it with normal force. It's got weight. There's a 405 Newton force pulling it to the right. And there's also friction, because they gave us the coefficient of friction here. So here is my free body diagram that describes the scenario. Okay, step two is to break forces at angles into components. Now, again, we don't have that going on here, so we can skip that step. Step three is to write out Newton's second law for each direction. Okay, so what I'm going to do here is I'm going to write down the x direction equation. So I'm going to write down m times ax equals the net force in the x direction. Okay, now in the x direction, I have this 405 Newton force going to the right, so we'll call that positive. And I got this friction force going to the left, so I'm going to call that negative. The mass is not known. And the acceleration actually is known. Take a look. It says in the question that the object is moving with a constant velocity. So if the object's moving with a constant velocity, then that means there is no acceleration. The acceleration is zero. So that means I get 0 equals 405 newtons minus the frictional force. Okay, so if you look at that, I can use that to find the frictional force. It didn't actually ask for it, but I'm going to need that anyway, as you'll see. So I'm going to find the frictional force. Okay, frictional force equals 405 newtons. So that's helpful. Okay. Now, in the y direction, this is what I have going on here. I have m times ay equals the net force in the y direction. In the y direction, I have the normal force going upwards, and I have the weight going downwards. Thus. And the acceleration in the y direction is 0 because it says it's being dragged across the floor. The box isn't accelerating vertically. It's not going up off the floor or down through the floor. So that's 0. But here's the problem. I don't know what m is, so I can't solve this right now. I have to think about what else do I know that I can use to help me here. And if you think about it, here's what I can do. One thing they told me that I haven't used yet is the fact that the coefficient of friction is 0.795. In other words, mu equals 0.795. Now, if you remember, there's a relationship between mu, the frictional force, and the normal force. It's the fun equation. Force of friction equals mu times n. Now check this out. I know what mu is, and I know what FF is. So if I divide, I can get N. So FF divided by mu equals the normal force. I have a frictional force of 405 newtons, and I have a coefficient of friction of 0.795. So if I divide those two, I can get, if I do 405 divided by 0.795, I get 509.4. Now if we look at what I did here in this step. The normal force minus the weight equals 0. So that means the weight must also be 509.4 newtons. And if I know the weight, I can find the mass by taking the weight divided by g. So 509.4 divided by 9.8 gives me 51.98, just around 52 kilograms. So when I worked through this example, it took a couple of steps and a couple of things that I had to think about, like the fact that it was constant velocity, so no acceleration in the x direction. Well, that's what I did here. I also had to remember that it wasn't accelerating vertically, it was sliding across the floor. And I had to pull in this relationship of frictional force equals mu times n. So it really tied together a whole lot of stuff that we've done in class into one question. It's a good study question.